Alright everyone, let's talk machine learning. Specifically, let's talk about how we can make it faster, like way faster. That's where GPUs come in. See, CPUs are great for general tasks, but GPUs are designed for parallel processing. Think of it like this. A CPU is a skilled chef, while a GPU is a massive kitchen crew. When you're training massive machine learning models, you need that kitchen crew. GPUs can handle millions of calculations at once, drastically speeding up training times. This means faster results, more complex models, and ultimately, smarter AI. It's like upgrading from dial-up to fiber optic, but for machine learning. Now, if we want to unleash the full potential of GPUs for machine learning, we need to understand the tools at our disposal. GPUs, or graphics processing units, are incredibly powerful pieces of hardware designed to handle complex computations at lightning speed. They are the backbone of modern machine learning and AI applications, providing the raw power needed to process vast amounts of data quickly and efficiently. But to truly harness this power, we need the right tool for the job. This is where the choice of programming language becomes crucial. While there are many languages out there, not all of them can tap into the full capabilities of a GPU. That's where C++ comes in. Known for its performance and efficiency, C++ is the go-to language for developers who need to get the most out of their hardware. It's not just about writing code, it's about writing code that can run as fast as possible, making the most of every clock cycle. Think of C++ as the ultimate toolkit for GPU programming. Just like a master craftsman needs the best tools to create a masterpiece, a developer needs C++ to fully exploit the power of GPUs. It provides the low-level access required to fine-tune performance and manage resources efficiently. C++ gives you fine-grained control over hardware and memory management, which is crucial for squeezing every ounce of performance out of your GPUs. This level of control is what sets C++ apart from other languages. It allows you to optimize your code to run faster and more efficiently, making it ideal for high-performance computing tasks. Think of it like building a custom gaming rig. When you build a gaming PC, you choose each component carefully to ensure maximum performance. You don't just pick any CPU or GPU, you select the best ones that fit your needs and budget. You handpick the best components for maximum performance, right? The same principle applies to programming with C++. You have the ability to choose the best algorithms, data structures, and optimization techniques to get the most out of your GPU. That's what C++ lets you do with GPUs. It gives you the flexibility to fine-tune every aspect of your code, from memory management to parallel processing, ensuring that your applications run as efficiently as possible. You get to optimize every little detail for blazing fast machine learning. This means faster training times, more accurate models, and ultimately, better results. In the world of AI and machine learning, speed and efficiency are everything. Other languages might offer some GPU capabilities, but C++ is like going straight to the source. It provides the most direct and efficient way to program GPUs without the overhead and limitations of higher-level languages. It's the language of choice for serious machine learning developers who demand absolute control and maximum performance. When you're working on cutting-edge AI projects, you can't afford to compromise on speed or efficiency. Trust me, your AI will thank you for it. By using C++, you're giving your machine learning models the best possible chance to succeed, ensuring that they run quickly, efficiently, and accurately. In the end, it's all about power and control, and C++ delivers both in spades. Okay, I know what you're thinking. C++, pointers, memory management, sounds scary. It's easy to feel overwhelmed when you first hear these terms. They sound like something out of a computer science horror story, right? But trust me, it's not as bad as it seems. But hold on, it's not as intimidating as it sounds. Let's break it down. Imagine pointers as the GPS coordinates for your data. They guide your program to the exact location where your data is stored. Just like how you use an address to find a friend's house, your program uses pointers to find data in memory. Pointers are like addresses for your data. They tell your program where to find the information it needs. Think of them as the backstage passes to the memory of your computer. They give you direct access to the data, allowing you to manipulate it efficiently. Memory management is like being organized and efficient with your workspace. You allocate and deallocate memory as needed, making sure everything runs smoothly. Imagine your computer's memory as a giant filing cabinet. You need to keep it organized so you can quickly find and use the files you need. Proper memory management ensures that your program runs efficiently without wasting resources. And then there's CUDA, NVIDIA's platform for parallel computing. CUDA stands for Compute Unified Device Architecture, and it's a game changer for developers. It allows you to harness the power of your GPU to perform complex computations much faster than your CPU could. CUDA lets you write C++ code that runs directly on the GPU. It's like having a secret language that unlocks the full power of your graphics card. With CUDA, you can perform parallel processing, which means you can execute multiple tasks simultaneously, drastically speeding up your computations. Don't worry though, there are tons of resources and tutorials available to help you master these concepts. From online courses to detailed documentation, you'll find plenty of material to guide you through the learning process. Many communities and forums are also there to support you, where you can ask questions and share your experiences. Once you get the hang of it, you'll be writing GPU-accelerated code like a pro. You'll be amazed at how much more efficient and powerful your programs can become. So take a deep breath, dive in, and start exploring the fascinating world of pointers, memory management, and CUDA magic. Happy coding! Now, let's talk about some secret weapons in the C++ arsenal libraries like cuBLAS, cuDNN, and cuFFT. These libraries are like pre-built modules specifically designed for GPU-accelerated machine learning. cuBLAS is all about lightning-fast linear algebra operations, which are the backbone of many ML algorithms. cuDNN is your go-to for deep neural networks, providing optimized routines for convolutions, pooling, and other common operations. cuFFT, as the name suggests, is all about supercharging your Fourier transforms, which are crucial for signal processing and image analysis in ML. Think of these libraries as performance-enhancing drugs for your machine learning code. They take care of the heavy lifting, so you can focus on building the next generation of AI. Section 5, Real-World C++ in Action, from image recognition to smart robots. So, where do we actually see C++ and GPUs in action? Everywhere. From the moment you wake up and check your smartphone, to the time you use your GPS to navigate through traffic, C++ and GPUs are working behind the scenes to make your life easier and more efficient. Let's start with image recognition. This technology has revolutionized the way we interact with the world. Imagine being able to point your phone at an object and instantly know what it is. That's the power of image recognition. Companies like Google and Facebook use C++ and GPUs to train models that can identify objects, faces, and even emotions in images. These models are incredibly complex and require immense computational power to train, which is where GPUs come in. This technology powers everything from self-driving cars to facial recognition software. Self-driving cars use image recognition to understand their surroundings and make real-time decisions, ensuring safety and efficiency on the roads. Then there's natural language processing, or NLP. This field focuses on the interaction between computers and human language. It's what allows your smartphone to understand your voice commands and respond appropriately. C++ and GPUs are used to build chatbots, translation services, and even AI assistants that can understand and respond to human language. These technologies are becoming more sophisticated every day, making our interactions with machines more natural and intuitive. And let's not forget about robotics. Robotics is one of the most exciting fields where C++ and GPUs are making a huge impact. From manufacturing to healthcare, robots are being used to perform tasks that are too dangerous or complex for humans. C++ and GPUs are used to create robots that can learn from their environment, navigate complex terrain, and even perform surgery. Imagine a robot that can assist a surgeon in performing a delicate operation with precision and accuracy. The possibilities are literally endless. As technology continues to advance, the applications of C++ and GPUs will only grow, opening up new frontiers in AI and robotics. From healthcare to finance to entertainment, these technologies are transforming the way we live and work. In healthcare, AI is being used to diagnose diseases and develop personalized treatment plans. In finance, algorithms are used to predict market trends and make investment decisions. C++ and GPUs are revolutionizing industries across the board. Whether it's creating more immersive video games, developing smarter home devices, or advancing scientific research, the impact of these technologies is profound and far-reaching. Section 6. The future is GPU-powered C++ at the forefront. As machine learning models become more complex and datasets grow larger, the demand for GPU acceleration will only continue to increase. And guess what? C++ will be right there at the forefront, empowering developers to push the boundaries of what's possible. We're talking about AI that can diagnose diseases with superhuman accuracy, robots that can work alongside humans in perfect harmony, and virtual assistants that can understand our needs before we even ask. The future is going to be amazing, and C++ will be one of the driving forces behind it. Section 7. C++ GPU resources. Level up your ML game. Now you might be thinking, this all sounds amazing, but where do I even start? Don't worry, I got you covered. There are tons of amazing resources available online and in libraries that can help you level up your C++ and GPU programming skills. Check out websites like NVIDIA's developer portal, Coursera, and Udacity for courses and tutorials on CUDA, cuBLAS, and other essential libraries. And don't be afraid to get your hands dirty with some code. The best way to learn is by doing. Section 8. Conclusion. C++. Your secret weapon for machine learning domination. So there you have it, folks. C++ and GPUs are a match made in machine learning heaven. C++ gives you the power and control you need to harness the full potential of GPUs, while libraries like cuBLAS, cuDNN, and cuFFT provide the tools you need to build cutting-edge AI applications. Whether you're a seasoned developer or just starting out, there's never been a better time to dive into the world of C++ and GPU-accelerated machine learning. Trust me, it's a wild ride and you won't want to miss out.